Hey y'all, in this video I'm going to go over the practice problems from the notes on atoms, ions, and isotopes. So the first problem says how many protons and electrons are in a titanium atom. The first thing that you want to note here is that it says titanium atom, not an ion. So in an atom, the number of protons and the number of electrons are equal. So if I just find titanium, figure out how many protons it has, then I will also know the number of electrons. So titanium on the periodic table is right here. It's number 22. That's the atomic number, which means that 22 is also the number of protons. So protons, 22, and because this is an atom, meaning that it's neutral, the protons, the positive charges, and the electrons, the negative charges, must also be equal. Number 2, what is the name of the element whose atoms contain 79 protons? So 79 protons means that it has an atomic number of 79. These are in numerical order, so find 79. That is Au, which is gold. So the name of the element whose atoms contain 79 protons would be gold. Okay, write the chemical symbol for the ion with 53 protons and 54 electrons. So notice it says ion because your charges are not balanced. It doesn't have the same number of protons and electrons. The first number, this 53 protons, that's going to tell us what element it is. So we're going to go on the periodic table, find 53. All the way over here, that is iodine. So my symbol for that is I. Okay, and here's where it gets a little tricky. It has 54 electrons. If this was a neutral atom, okay, not an ion, if it was a neutral atom, it would have 53 electrons. Okay, E with the negative sign is the abbreviation for electrons. If it was neutral, these would be true. Okay, this is not the case. I have one more electron, and electrons have a negative charge. So if I have one electron extra, that means I have a -1 charge on this. So this would be your chemical symbol for the ion with 53 protons. That would make it iodine. And then 54 electrons. You gained an electron. You gained a negative charge. Okay, this ion did. So it's -1. Or you'll sometimes see it just like this with no 1. Number 4, how many protons, neutrons, and electrons are present in this ion? Okay, so you have Ag, which is silver. You have 108, 47, and a plus charge. And we need to figure out the protons, the neutrons, and the electrons. Okay, protons. Protons will be your atomic number. Okay, it's this number, 47. Okay, or if you forget that and you see it's Ag and you know that you can get your number of protons from the periodic table, you can do that as well. So Ag is here. That atomic number is 47, which means that it has 47 protons. Okay, the next one that I'm going to do is neutrons. When your chemical symbol is written like this, let me try that one more time. This is the complete chemical symbol. This number at the top left is your mass number, which means that because electrons don't really have much mass, your mass number is your number of protons and neutrons added together. Okay, so to find this number of neutrons, we're going to do 108 minus 47, because remember 47 is the number of protons. So 108 minus 47 is 61. So 61 neutrons. Okay, number of electrons. We have to do this problem that we just did, but backwards. So keep in mind that this has a +1 or a plus charge. Electrons have a negative charge. So in order for something to be positive, a positively charged ion, a cation, it had to have lost an electron because it has to lose a negative charge in order for me to be positive. Okay, just like in life, You want to lose those negative things in your life, you're going to be more positive. Okay, so we had to have lost 1 electron to have a positive 1 charge. Okay, well, how many electrons do we start with? Okay, the number of protons would equal the number of electrons if it were an atom. So I would have 47 electrons if this were neutral. Okay, but it's not. I got rid of a negative thing, so I'm more positive. So if I had 47 electrons, but I lost 1, that would mean I only had 46 left. Okay, we're going to do that same thing again, using those same things that I just said, but we're not starting with this. This is what we're trying to write. Okay, instead of giving us this symbol and we have to say how many of each of these we have, we're doing it backwards. Okay, so 63 protons. First thing is, what element is that? Okay, look on your periodic table. 63. Right here, europium. So Eu, that's the symbol that I'm going to start with, Eu. Okay, and then your number of protons goes down here, 63. Okay, up top, this is your mass number, where all the mass comes from. That's your protons and neutrons. Okay, those are the two things that are in the nucleus. That's where your mass is. Electrons barely have any mass. Okay, so I'm going to add these two, 63 plus 88. That'll give me my mass number of 151, and that goes up here. Okay, then we have 60 electrons. Remember, if it was a neutral atom, I would have the same number of protons and electrons. So I would have 63 electrons, but I don't. I only have 60. So I lost 3 electrons. Okay, if it was an atom, my 63 protons would need to equal my 63 electrons, but it doesn't in this case. I lost 3 things, 3 electrons, 3 negative charges. I got rid of negative things, so I became more positive, okay, by 3, because I lost 3. Or you can look at it as a double negative. You lost, so minus negative 3 things. Okay, 3 things. They each had a negative 3. Or they each had a negative 1, but it was negative 3 altogether. And if you have a double negative, that becomes positive. Okay, minus a negative is positive. So that's the answer for this one. Last one, how many protons, electrons, and neutrons are in chlorine 37? Okay, protons, electrons, neutrons. Chlorine is right here. It has 17 protons. That's the atomic number on the periodic table, so that's how many protons it has. Okay, does this have a charge on it? No, just chlorine 37, no charge at all. So that means that your protons and electrons must be equal. This is an atom. Okay, more specifically, this is an isotope. This is your chlorine dash 37. The 37 is your mass number. Okay, this is an isotope. It hasn't lost or gained electrons, but it has either lost or gained neutrons. It has a different number of neutrons. Okay, this is your mass number. So to get your number of neutrons, you have to do your mass number minus your number of protons. 37 minus 17 is 20.